Welcome, welcome everybody. My name is Greg Carbonetti and this is Science Unplugged. We're coming to you from the Alan Alda Center for Communicating Science at Stony Brook University.
Our guest today is Amara Saeed. So let's go straight into it. We'll say, what do you do and why is it important?
Okay, so in our lab we create some mutations in the zebrafish that are going to give the zebrafish the same characteristics as people with autism have.
So we'll step back a little bit. Okay. So for a zebrafish, right, is it basically a fish that looks like a zebra or is it patterned? Like what exactly?
So it has stripes, black and white stripes on it. There's another kind of zebrafish that has leopard print, so we call it leopard. But the species is the same. So most of the fish, they have black and white stripes, and it's a very small fish. Like the most that it grows, it's still 6 centimeters, and that is that is the extreme case. But most of them are like 1 to 2 centimeters.
Cool. So you've got these zebrafish, and you said you're giving them genetic mutations that will hopefully help them display autism spectrum disorder.
That's right.
And then what are you going to do with them? Is this going to help us with autism research, obviously, or how is this going to really benefit us, or why is this something that's worthwhile for pursuing?
So the thing with autism is that autism is a very broad disorder.
Yep.
It's actually a spectrum disorder, which means that it has all different kinds of characteristics, and the main characteristic of autism is the behavioral changes that we see. So if we what we do is that we create the mutations and then we screen the fish so that we get the same, we get the fish that has the same characteristics as the autism spectrum disorder, and then we can come down from there. Okay, so this fish has these characteristics of autism, so now let's see the biology of like what is going on behind it.
So these fish act differently?
Yes, they do. They have they have higher anxiety. Sometimes they will have they're very afraid of their environment. Any new environment that comes in, they're just, you can see it there's a stark difference in the normal fish and the autism fish.
So if I'm understanding correctly, what you guys are doing is you're creating certain mutations, not in a particular way, just broad mutations, and then you can sort them into different groups based upon the behaviors they're displaying, and then you can actually look back in and see if those correlate to a specific, genetic marker. That's really cool.
So to correct you,
please.
What we do in the lab is that, so autism has like estimated number is 564 genes that are mutated in the autism spectrum disorder.
Wow.
So we don't just target all the genes broadly. What we do is that based on the research that other people have done, they have narrowed down a list of genes, a number of genes that have bigger impact than the other genes. So then we target one of those genes. We go one by one, because again, with these genes, right now we don't even know with most of these genes what they actually do in the normal situation. So then how can we find out what they do in the mutated situation? So first we have to be very specific about like one gene. What does it do? What does it do in the normal one? And what does it do in the mutated one?
Cool. So we've got a lot flying around here right now, and this is really cool stuff. So for somebody that isn't as well versed in genetics as I'm sure a lot of our audience is, how do you go about making these specific mutations in an actual fish? It sounds like a pretty complicated procedure.
It's actually not complicated, and the reason behind it is that our genes are made up of DNA, and the DNA is made up of only 4 nucleotides. So all these 4 nucleotides, they are...
So nucleotides. So we would have the jargon, please, here. You get jargon. Okay. So these nucleotides, these are the 4 building blocks that make up our DNA, which make up our genes, right?
Yes.
Okay.
So 4 building blocks that are arranged in different orders, and they go up to different order, A, B, C. So some next one will have C, B, D, something like that. So these 4 building blocks, but they're very large building. They're molecules, so they're small, but
there's lots of them.
In terms of number, there are 35,000 nucleotides put together. There'll be one gene.
Wow.
So, but in that gene, there are different there are different parts of the gene. Some parts that that work different than the other parts, and so we know about that one part of the gene that we can target directly. That falls because genes make proteins, right? So we want to target a part of that gene that will make up the crucial part of the protein.
So you're just picking these particular places,
Yes.
not the whole thing.
Yes.
So, I mean, even more important now. So we've got a little science, we've got some genetics, we've got these zebrafish. You're able now to, look back and see what these actual mutations are in these particular genes that may be causing these behaviors that are on the autism spectrum. How is this going to help people or families that have members with autism spectrum disorder?
And to kind of add to that question before you continue, like why do we use zebrafish as something to study autism when this is in people?
Oh, we're throwing them at you.
Yeah,
You better
sorry.
be ready here.
So first, to answer your question, now zebrafish is a really cool organism. So most of the time you hear about, when you hear about research, you hear about rats. Rats and mice, they're used a lot. So the thing with mouse and rat is that, let's say that we want a new generation of mice that are mutated. So you mutate the mother or father mice, and then when you get
They fall in love and they make a baby mouse. Yep.
Yes, and by the time the baby comes out, it's 2 months have passed. But the case with zebrafish is that you can just put them in a tank, and the next day you get like 200 eggs.
Because the generation turnover is really quick.
And the zebrafish larvae, they are transparent, right? So you can put them under the microscope, and you can see each and every cell layer
Oh, wow.
of their
That's
body.
amazing.
Yes. So it allows scientists to be very specific with their changing the mutations. So we can change in
So
very
how
specific.
big are these zebrafish that you see? Because you can see under the microscope.
Yeah, so the zebrafish larvae, they are at maximum less than a centimeter, maybe like 7 or 8 millimeters. Very, very small.
But the adults get a bit bigger.
Yes, that gets to be bigger.
So, and then we were saying, like, how can this research really help these families that have autism spectrum disorder within them?
Yeah, so by first, the thing with autism is that, as again I've said before, that the biology of autism is not really known really well. So the molecular biology, what is going on the molecular level, like what is all these proteins and all these enzymes are doing that is creating the autism. And autism is seen in the form of behavior. So the behavior itself is a very complex phenomena. So our goal is to narrow it down to the very small parts of our body, like the cellular level and the molecular level, so that we can maybe create treatments or create some more drugs.
Yeah, so, I mean, we have to understand what the problem
maybe,
is.
like screening methods, because a lot of times, I don't know if this is like fully correct, but a lot of it, like the behavior you mentioned, is you notice it when they're like 2 years old or a little later. So like if you have like your molecular biology tools, like maybe you can detect it earlier and maybe do like some sort of what's it called, like intervention.
Yeah.
Right.
And the cool thing with zebrafish is that they have very specific behaviors at specific age. So let's say that at one day after they're born, they have this coiling behavior that they do, like 20 coils per minute. So that's the normal one. So the behaviors are so specific that just by looking at the behavior, you can age and track down the age of the
wow.
fish. Yes.
Pretty
so,
cool.
It allows us to be more specific with what we're doing.
Cool. So I got another question for you, Amara.
Sure.
What made you wake up one day and say, I want to work on autism spectrum disorder in zebrafish? It seems like a pretty specific thing. What influences you, or what is it you love about what you do that made you, want to pursue this kind of science?
So I did not, I had not in mind to go in specifically in autism. I just kind of went into it. My goal behind it was that I had worked in a disability support office, and there were all these people coming in, and when you look at them physically, they're just fine. They're just like me and you, and they're perfect. They're beautiful, handsome people. And then when you look at their psychological evaluation, they have all these different kind of problems. There are emotional problems. There are intellectual problems. So I was like, wow, this is something that is very different, and it's very interesting too. And so yes, I applied for I knew that I wanted to go into neurobiology. So I just
Like anything
That
else in
sounds
life,
scary,
you kind of
yeah.
fall into it. Cool. All
So
right.
we'll actually
Roll it back
take
a little bit.
science, and we'll go. Maybe there's some science questions in this.
Yes,
but,
we'll see. Quiz time. Everybody's favorite time.
I think this is a little easier than the last one. I hope.
Yeah, so we just, we
Yeah.
do a couple of shows per day, and we just had one, and oh man,
I'm
we
sorry,
hit
it's
her hard.
brutal. Yeah.
It's all right. We'll
But
see, Amara.
I'll
You
be
might get
nicer
it just
this
as
time.
bad. We'll find out.
All right, so this is another one of those name questions.
Okay.
Which British singer was born Florian Cloud de Bonneville Armstrong and had a smash hit debut album in 1999? Do you need a hint?
Yes.
Eminem sampled one of her songs in his song Stand.
Ah, I think I know this.
I don't know.
This would be Dido.
Exactly.
What is
You
that
would
name?
have to change your name if it was that long, right?
Yeah, because she does stand with him, and that was like, God, I'm feeling my age now.
was junior high school.
What is her name? Her first name is Fleury?
Florian,
Florian. Oh, that's actually kinda
F-L-O-R-I-A-N,
pretty.
Florian Cloud de Bonneville Armstrong.
All right, you get a pass on that
Yes.
one, Amara. Don't worry about it. That's
All right,
fine.
this one might be better. So step it back a bit. Snoopy from the comic Peanuts is what breed of dog?
It's pretty common.
I'm sorry.
Don't apologize.
Who's writing these quizzes? I'd like to find out.
I don't.
I think she's behind the camera over here. If I'm not mistaken, Snoopy is a beagle?
Yes, it is.
All right, there we go.
All right. Okay, next one. Okay, this
Sorry,
is
Amara, I'm on your side. This is getting brutal here.
current events.
Current events.
Which decorated U.S. figure skater and partner are going down divorce lane? Just like the figure skater.
U.S. figure skater, and who
Yeah.
else?
Decorated, and she's a female. That's a hint. Big hint.
Ah,
I'm never good with names.
I know. I mean, Nancy Kerrigan?
A little bit after her.
Tanya
She was
Harding?
around the same time. She was around the same time.
Tara Lipinski? Why do I
She
know
was
these
actually her
figure
direct
skaters? I don't
competitor. She was
understand.
actually Tara Lipinski's direct competitor.
I have no idea.
Michelle Kwan.
Michelle Kwan.
Unfortunately.
So, just to defend myself a little bit, during this figure skating heyday, I mean, I was little, maybe it was like
enjoyable,
8,
though.
9, 10.
You had good music.
We used to sit down and watch the Olympics, and
it's a family
okay,
thing.
I'm a closet figure skater lover. There it is.
All right.
It's out there.
It's okay.
Amara, now you know, our audience knows. Don't worry about it. All right, we're up to number 4
Fourth question.
of this brutality. Continue.
Which animal has the fastest metabolism?
Animal with fastest metabolism.
Animal with the
We could talk about size. A hint would be it's
Ooh,
small.
ooh. I think I might know.
Is it a big one? Is it small?
It's small. Definitely very small.
I think it flies.
Yes.
I think it flies.
Very fast.
I think it has a long thing.
Cheetah?
No, it flies. It flies. Well, cheetahs do fly, sort of, in terms of speed.
Yeah, in speed. I think this actually flies. Is it a hummingbird?
Dragonfly?
It is a hummingbird.
Hummingbird. So I wouldn't bet. See, but that's what I was thinking because the fast
Yeah,
wings.
fast wings.
You know
It is
what?
the fast
Maybe the
metabolism.
quiz isn't so bad. It's
I-
just I get so excited that I don't let Amara answer the actual
this-
questions.
Okay, the last one.
Okay.
I think you might know it, but then let's give it to
Okay,
you
I'm
first.
keeping quiet.
All right, last question. What is the name of the new trilogy in the Fast and Furious franchise? Maybe this is a bad question.
The new trilogy.
Yeah, maybe you don't know.
You know what? My brother, if he was here right now, would hit me in the head because these are like right in
Phone a
his.
friend.
Yeah, I would absolutely phone a friend. Amara, any wild guesses here? The slow and the nice.
I just heard
It's-
that.
it's
the
in
new
Fast and
trilogy's
Furious,
coming,
like the
but,
name.
All right, I got nothing.
Okay, so it's actually the fate of the Furious.
The
Fate of the
fit.
Furious.
All right, well there you go.
Right, so that's
So,
the end of the torture.
I think we learned that no, Amara, you were not going to get an easier quiz, and you got brutalized
Sorry.
just as bad. That's okay. It's quite all
I was
right.
trying to give hope so that maybe you would get it. Yeah.
I know.
Yeah.
All right. Well, before we let you off the hot seat, Amara, we got one last question. You want to hit her with it, Wendy?
So since we're on this show, like the purpose is science communication. So for you, why is science communication important?
So yes, science and communication is very important in the respect that, especially when you talk about, with parents who have kids with autism, and they want to know more about why their kids are the way they are, and they want to learn more about what's going on with them. They want to empathize with their kids as well. So science communication, it helps us break down all these complex phenomena that are happening, and then tell to the parents. For now, now that there's no treatment present for autism, but there is just one way of us telling, sympathizing with the parents that okay, this is what is going on. And the second thing is that the general public, in general, they want to know about why, what is going on behind the labs, and why is it important, why are these people's taxes, millions and millions of dollars are going in the labs, and nothing really quick is coming out. So we have to let the general public know as well that this is a long process, it takes time and all these things, but so science communication really helps in that aspect as well.
Yeah, it's really cool, Amara. And what I would say too is, I know a few people that actually have autism spectrum disorder, and I'm close with their families, and a lot of times you'd hear their families say, there is nothing wrong with them. This is who they are, and they're a great person. But I usually counter with, but that doesn't mean that we can't learn more about it. That doesn't mean that it's not important to learn more about it. And in the future, that could wind up helping a lot of people, and people like you, Amara, are the ones leading the charge, and we're really thankful for it. So
we'll have Greg take us home.
I think so. Amara, thank you for joining us.
Thank you for having me.
I think she's off the hot seat now. Wendy?
We're still on the hot seat.
We're still kind of on the hot seat, but you'll be on like a flying seat on your way to San Francisco tomorrow. So have a safe trip.
Definitely, thank you.
On that note, once again, we are Science Unplugged. Thanks for joining us today. We come from the Alan Alda Center for Communicating Science. And please join us once again. Our show has everything. We have figure skating, we have Snoopy, we have a little bit of autism spectrum disorder.
We have Dido's very long.
We have Dido, we have I don't even know what that is. A little bit of Full House sprinkled in. It's fun. Please join us again. We'd love to have you. And on that note, take care, everyone.